Welcome back. This is the third video of chapter 7, and we're going to start this video off by talking about the range-based for loop. This is nothing more than a specialized for loop, and it was provided to us in C++ version 11. It allows us to do a loop that iterates once over each element in an array. Now, this is pretty cool because this is something that a lot of our other higher form languages have already. So C++ came along and added this for us, and we're going to take a look at how it works. One of the things to notice is that when it does iterate through the loop, it copies the element from the array to a built-in variable known as the range variable. So when you are working with it, you're working with a copy of each element. You're not actually working with the element itself. The range-based for loop automatically knows the number of elements in the array, and so you don't have to use a counter variable, and you don't have to worry about stepping outside the bounds of the array, which is really nice. I mean, there are upsides and downsides to this. For example, the fact that you don't have that counter variable can be problematic if you need that counter variable. Oftentimes when we're doing for loops, we need that counter variable, and so sometimes this range-based for loop is just not the ideal solution. But oftentimes it is. Oftentimes that's exactly what we need to do. We just need to iterate through the items of an array, and so this is where that range-based for loop. Now, forgive this slide for the messed up in the font, but we can still read everything here. So this is exactly how the for loop, the range-based for loop looks. We're going to specify the word for, and we're going to have our array here. And this is where we're going to declare, so this is the type that this array is. And this is where we're going to declare a name for us to make use of when we iterate through the array. So let's take a look at what that looks like. So here we have a simple program, and in this program, we've got an array of numbers that we've declared. We explicitly declared the array, and so this array has 1, 2, 3, 4, 5 items in it. And as you can see, let's grab our nifty little pen here. This is the array, and so here's where we're specifying the array. It's of type int. And this val is where, as we're iterating, it's going to copy each one of these elements into this variable. Now, again, want to remind you, it's a copy. So if we try to manipulate it, it won't manipulate the original array. And so just kind of keep that in mind. So once we have that variable, now we can use that variable. So as you can see, this is us using that copy. We're just outputting it in this actual. All right. So modifying an array with a range-based for loop. As the range-based for loop executes, its range variable, the contents are copied into the arranged element. You cannot use a range-based for loop to modify the contents of an array unless you declare the range variable as a reference. Oh, so again, right away we see this rule that we've created, which is you can't modify the items in the array, but now I'm telling you that there is a way to do it. And you're going to find that with most programming items is there's a bunch of ways to do things, and oftentimes you'll hear well, you can't do this unless you do this, right? And that's just normal in programming. This also gets back to something we've already looked at, which is using the ampersand sign to declare that we want to, instead of actually get a copy of each item, we want to actually look at the elements inside the actual array itself. And so with that, we can actually modify the items in the array using the range-based for loop. So what does that look like? So here's the big difference. This allows you to make changes to the actual item in the array. If we do this, we're telling the compiler that when we're running through this, rather than just get a copy, we want to actually look at the item in the memory where that array is. So we're actually saying go to the array and actually use the items in the memory at that spot rather than give me a copy. So that's exactly what's going on here. And because we do that, we can, as you can see, modify what's in the array. Get used to this symbol. That's one of those symbols that in C++ you're going to use a lot. There's a symbol that goes along with this symbol that you're also going to start seeing here soon that's known as a pointer, and it's just a star. We'll talk about that a little bit more in the future, but again, this is one of the unique things to some of these lower level languages like C++. Oh, it's not giving me my erase here. Well, I guess we're just going to do it by hand. So that's one of the things that is not unique to C++ per se, but unique to lower languages like C++. We have the ability to manipulate things at memory addresses. And that's kind of what we're doing here when we use the @ sign, stuff like, the ampersand sign and the pointer sign, which we'll see in the future. So here is another version of us using the range-based loop. But in this case, because we're not using the ampersand sign, we're just going to get a copy of the item in the array. Now, one thing to keep in mind is you're saying, well, Professor Waits, well, if that's the case, if these two simply do the same thing, except this one allows me to modify the contents and this one doesn't, well, then why don't I just always use this one and just make my life simpler? The reason being is good coding practices say you should do just the opposite. Always try to use something that won't alter data, because this means your program can't accidentally alter data. It can't mess up your data. It can't corrupt your data. So use this sparingly. Only use this if you really, truly have to modify data. Otherwise, avoid it. Use the read-only version instead. So that way you can make sure that your program doesn't even have the chance to mess up data. All right. So you can use the auto keyword with a reference range variable. For example, in this code, in code 12 through 16, you have written like this. And the reason why you can do this is this tells the compiler, hey, figure out what type of array this is and just make this that type. We can do that because the compiler is always going to know well in advance of what type of that array is. And so at compile time, it can automatically figure that out. I also tell people, and we have this in other languages as well, and I always tell people, because this becomes one of those where we just start doing it all the time, and I always tell people, please avoid doing that. While, yeah, it works, there's a little bit of laziness that goes along with that, and also it makes it a little bit more difficult to read people's code, because I'm not the compiler. I don't have I haven't seen all the code. I can't look at the code all within a matter of seconds to minutes, right? And so if I'm looking at this code and I'm either code reviewing this, or let's say I'm making a change, I'm debugging the code, there's a problem, I'm going to have to, if I need to know what type of array this is and what this type this value is going to be, there's a chance because of this auto, I'm going to have to look up in previous code to try to find out what type that is. So I always give the advice to developers: use this when needed. Don't use it as just an easy go-to. To just type out code and be done with it. Only use it when, because more than likely when you're typing out your code for the first time, you already know what this numbers is. So if you don't need this auto, if there's no real reason to use auto, go ahead and actually use the data type like int. The range-based for loop versus the regular for loop. So the range-based for loop can be used in any situation where you need to step through the element of an array. You do not, there's no need for the element subscript. What I find is, for me, it's the opposite. I usually will use the range-based for loop most times. It's when I come across the fact that I need that subscript for some reason. Something about that subscript is going to be needed in my code, and that's why I'll use the for loop. So while this is just kind of giving an example of the range-based for loop versus the for loop, I feel like this slide is kind of going backwards. Like they're saying, hey, use the for loop unless you don't need the subscript. Well, I always say I use the range-based for loop unless I do need the subscript. It's the same way of saying it. It's just I default to the range-based for loop before I look to the regular for loop. If you need the element subscripts for some purpose, then use the regular for loop, which is, again, exactly what I was just saying there is use that for loop last if need be. All right, let's talk about processing some array contents. Now, this slide, when you first read it, it's kind of like you want to go, yeah, that makes sense. Why would I do that? But this is actually something that does happen, and I've seen it in development. It's one of those silly mistakes that, it's one of those, oh, I put the decimal in the wrong place kind of silly mistakes. Not that you've actually put the decimal in the wrong place, but it's those silly little weird mistakes you're going to make that they're usually hard to find in the code because they're so silly and so simple. So kind of keep that in mind is when you're using something like the increment or decrement operators, that this, by the way, increments the actual item in the array at position I. So this is going to add 1 to test subscript I. Where this one will get the item at I and return that. And then after this line, it will increment I for you. So your pointers, your subscript pointer is now one more looking for the next element. So just be careful when you're using items like this that as you're processing through arrays, you're using the correct or the wanted way of doing things, whether you're incrementing or decrementing. Now, this is really important. So out of the gate, C++ does not allow you to copy arrays to other arrays. You can't say, hey, I have this array test, and I want to make a new array called new test and just copy that in there. Unfortunately, C++ doesn't work that way. A lot of it's because it has to do with assigning and creating the memory space that's needed for the array. And again, remember, for C++, arrays are sequential in memory. So they are each piece of, each block is right next to its previous partner. So instead, to do that, unfortunately, you just have to iterate through the array, and you have to assign each item or copy each item, I should say, into the new array. You also are going to have to create the new array, remember, you need to create what size it is. So you're going to have to take and find out what the size is of test when you make your new test array before you start assigning items. Pretty simple. If you're not using a char array, which is a fancy version of string, but if it's not a char array, you can't just output it. You can't just say C out and put the name. If it's a char array, you can do that, but only if it's a char array. Again, if you want to do this, you're going to have to go item by item and output each item in a row. So let's say, and by the way, if you need to put each item on next to each other, again, you just would not put the end line here. But this is how you would output an array of ints, each item. By the way, this is not a fancy way of getting an array size. This was just, they obviously at some point previous in the code, this array size stood for the size of test. And so that's why they're using that. But that's not like any cool built-in C++ thing. And this is, again, where that range base comes in really handy, is, again, for C++ 11 and up, you can do the range based, and it actually works pretty neat, and it's a little less typing, and it actually reads. I think it reads cleaner. So as a developer that's coming back and looking at code, this looks nicer. It reads cleaner, and I quickly know what's going on. Again, as you can see, I'm glad that they put int here rather than auto. Because if they put auto, I would have to look up in previous code to find out what kind of array this is. Because as you can see, nothing about the rest of this for loop tells me or indicates what type of an array that is. Only this does. So if that was used as auto, I would not know initially what kind of array that is. So when it comes to summing and averaging array elements, there are some methods and functions that we will talk about down the road that allow you to do this. But because we're first cracking open C++ for the first time and we're just using it, unfortunately, out of the box, out of the gate, without getting too fancy, if you want to sum or average the array, you just have to do it by hand, and you have to iterate through the item, summing it up. So as you can see, I'm just iterating through the loop here, through the array, and each item I'm adding to the sum. Once I have the sum, I can then quickly, you go ahead and do an average, because it's just the sum divided by the number of elements. In C++, once again, we can use a range-based for loop. And as you can notice, again, I'm using the by value version here. I don't have that ampersand sign out front because I don't want to accidentally make changes to that number. Now you're saying, well, Professor Waits, I'm looking at the code and there's no real way that this code could cause problems with that val anyway. So why do I really care about that? And here's why. Because you're right. Maybe you're right. This code has no real value to changing the data, and you can see that, and that's great. And that's great all the way up until someone else comes behind you, and there's maybe an issue, or maybe there's a code change request that comes in, and they come in, they start messing with your for loop, and they accidentally develop code that changes that val. Now you have the potential for messing up data. So again, just help everybody out. If it doesn't need to change the data, don't put that ampersand sign out there. Why take the chance? This is a neat little way to find the highest value in an array. I don't want to spend too much time on this because you can look at this code yourself and kind of see what's going on here. Again, we're just going to loop through the code and if the current value that we have stored in our kind of our flag, I wouldn't even call it a flag, just our a variable that we have, if the new value is higher, then we put that into the highest. Pretty much the same way to do the lowest value, just the opposite. But we have this kind of this register variable where we're storing a number until we find another lowest number, and then we put that number in the register variable. Partially filled arrays. So when it comes to arrays, there's something that we haven't really talked about, but I need to let you know is, unfortunately, once you create an array of a certain size, you can't make it bigger or smaller. It is what it is. And that's really bad if you need to make it bigger. Making it smaller is exactly what we're going to talk about here, which is a partially filled array. And we have ways around that. But making it bigger, you can't. And Professor Waits, C++, it's an amazing program language. Why can't it do that? It comes down to, again, the fact that the array has to be stored in memory in consecutive order. Chances are, by the time you have created your array into now where you want to fill in or you want to make that array bigger, the memory spaces next to that array have already been used. Again, the system doesn't want to really handle keeping that in mind and figuring out whether it needs, the memory space next to it is bigger or not. So if you need to make an array bigger, the only real way to do that is actually to go and create a new array of the larger size and then copy the contents of the current array into the bigger array and then kill the original array. And so, again, it's not, but the point of that is you're not really making the original array bigger. You're literally making another array that's bigger and copying the contents. So keep that in mind when you're developing your code is, if you don't know what the size of your array might be, maybe you're sitting there going, well, it can be between 5 and 10 pieces of data. Always go with the larger of the amount, and then just have a variable that keeps track of how many items are in that array. So that way, when you go to use that array, you're only using the pieces that have been assigned. And again, that's why I said it's easier to technically make the array smaller. And you're not making the array smaller, you're just using only a portion of the array. And that works. I guess, good developers will come along and argue, well, obviously, as you're doing that, if you're doing that all the time, you're now wasting memory. And so, I've written C++ apps that have array sizes that are just massive. And so, that would come in handy. I mean, that would play a part is if I'm only using partially filled massive arrays, then I am wasting memory and might make the system small, slower and so forth and so on. For the most part, most people aren't getting to that size of arrays, and if they are, they're thoughtful about it. So, partially filled arrays not a bad concept. There are other ways to do it as well. But again, just kind of recap on that. Partially filled arrays are arrays that you go with the larger size of what you think the data is going to be, but you have a counter to keep track of the actual size of data you're using. When it comes to comparing arrays, you have to go element by element and compare the arrays. So in this case, we have these two arrays, first array, second array, and we're going to go item by item to check to see if the arrays are equal. And then if we find something that is not equal, we would update our flag, and we can see that our flag variable right here is arrays equal to false, and then we would use that later to indicate that whether the array is truly the arrays are truly equal to each other or not. All right, so on the next video, when you guys come back, we're going to start talking about using parallel arrays. For those that have been around the developing world for a little bit, you're going to go parallel arrays. Those look very much sort of like a dictionary list, and they are. For those that are new to programming, we'll talk about what parallel arrays are, and we'll even make a little mention of what I just said, which is the dictionary list. All right, I'll see you in the next video. Thanks.